Troubleshooting FlexVPNs. Let's begin. There are quite a few moving parts inside FlexVPN, and it's very likely that in our future we're going to have the opportunity to troubleshoot and resolve issues that come up when we're trying to get FlexVPN to work. So what you and I get to do in this video is take a logical approach to solving a FlexVPN problem. The first thing I'd recommend is make sure we have basic connectivity. If R2 is a spoke that we're bringing online and we need to connect over to 15001, we might want to just do a basic connectivity check to make sure that we have access to that device, that it's up, it's reachable, it's the right address, and so forth. If R1 doesn't have a static address, it changes from time to time, we can, inside of the FlexVPN client, we can point to a fully qualified domain name and then put the fully qualified domain name that's resolvable via DNS inside of that client profile, and then follow it up with the keyword dynamic, and then in the client configuration it'll leave that fully qualified domain name. So in the future, if that IP address is different and this client has to come back online, as long as we've reflected whatever that new IP address is on R1 inside of DNS by using dynamic DNS or whatever method we want to use, if it's resolvable to the correct new address, then the client can reconnect and continue to function. So basic connectivity is a huge plus in the world of doing an overlay like FlexVPN. Next, we might take a look at a single spoke coming up to the hub. Now, if we have 3 spokes and 2 of them are working successfully with the hub, it's very likely that it's the configuration locally on R2 that's causing the problem. He's the odd man out. Or if all of a sudden they were all working and now none of them are, we would want to take a look at the configuration changes on the hub if there were any, or take a look at some type of catastrophic failure for the basic connectivity. So the connectivity that's required is UDP, port 500 between the devices. That's for the IKE v2 negotiation. And then ESP is protocol number 50. And if there's NAT that's between these devices and NAT traversal kicks in, we'd also want to make sure that UDP port 4500 is also available between the 2 devices. The next question we might ask is, do we have reachability, for example, from the hub to this remote network, 10.3.3? Or does this remote network have access to the 10.1.1? And if that's not working, it could be because we don't have our child SAs in place, the IKE v2 never completed. We could do a show crypto IKE v2 SA and take a look at the status. If it doesn't say ready, guess what? It's not ready. If it says negotiating or deleted, we'd want to go back and look at our policies to make sure we have compatible policies. If we're using pre-shared keys, make sure we have the correct keys set up. And a big part of the reachability could just be routing information. I mean, R1, when it wakes up, doesn't just know about 10.3.3 based on an accident. It's going to need to be told that either through a routing protocol that's running on top of our VPN architecture, or if we're using an IKE version 2 authorization policy, we could include that network in an access control list and advertise it that way via the IKE v2 tunnel. And it's really important because all of our VPNs depend on routing, because our routers have to be willing to forward a packet through an interface where on that interface there's either the older crypto map or an IPsec profile that's going to activate an encryption policy on that traffic. Another thing we want to check is our policies and profiles, and oh my goodness, there's a lot of them, aren't there? And if we're using the defaults, we'd want to verify what those defaults are, because as you and I know, they can be customized. Also, the defaults can be disabled. So if we accidentally said no, crypto IKE v2 policy default, we could actually disable a default policy that if we thought we were using is not going to be too effective. And throughout this course together, we have looked at a lot of commands to identify the contents of the profiles and policies associated with both IKE version 2 and with the IPsec portion, including transform sets and the IPsec profiles. Now, if everything up to this point is working, that's a pretty good deal. However, if our traffic is still going over the hub and we want to go ahead and make sure it goes directly spoke to spoke, for example, traffic from the 10.2.2 subnet to the 10.4.4 subnet, optimally, that would go directly back and forth. And what would cause that not to work? Well, perhaps we don't have our NHRP redirect command enabled on the hub, or maybe we don't have the NHRP shortcut command enabled on the spokes, or perhaps the NHRP network ID is different. It needs to match between the hub and the spokes if we want the NHRP to work. And one of the cool things about FlexVPN and also dynamic multi-point VPN is that they both have the ability to cut over and build shortest paths directly between spoke to spoke, and these IPsec networks, DMVPN and FlexVPN, we can go ahead and run multicast applications right on top of them. So if we've got a multicast server sitting here at the central site, and we have multicast clients who've joined that appropriate group, we can effectively have a multicast enabled network over the internet. We're going to start on R4. Let's do some basic connectivity tests just to verify we have reachability to the public-facing interfaces on R2, R3, and R1. And the ping to 15.0.0.1 works, the ping to 25.0.0.2 works, and the ping to 35.0.0.3 works. So that's our first step, basic connectivity. Now, if we wanted to verify our connectivity, for example, from this spoke R4 up to the hub, or for anyone else that we have an IPsec or IKV2 session with, we can do a show crypto session. And this shows us that we have two IKV2 tunnels, this one and this one, along with the children IPsec essays associated with each of those tunnels. So this one right here is between us and R1 based on the IP address of the peer. And the one that's using the virtual access interface is between us and R3 based on the IP address. Now, in one of our videos, we implemented a FlexVPN client with a client profile. If we had done that here on R4, when we want to see the details of that, we do a show crypto IKV2 client with the keyword FlexVPN. Now, on R4 currently, we're using a static tunnel interface to build the tunnel between us and R1. And we've also configured a virtual template that allows us to create the virtual access interfaces. We don't have, at the moment, on R4, a VPN client profile configured. Otherwise, it would show up right here in the output with the details. If we want to take a look at the details of our tunnel interfaces, we can do a show run for interface, for example, tunnel 0, if that's the interface we're using. And we want to verify the configuration here. And the key things I would look for is the tunnel mode. Are we specifying tunnel mode IPsec IPv4, or are we leaving it off? Make sure that's consistent with what the hub is using. Or if it isn't, make sure at least the hub is compatible with auto, where it can automatically figure out the type of connection based on the incoming request. So if the hub supports that, it may not be an issue, but if it doesn't support it, they would have to match exactly based on the tunnel mode. If we're using NHRP, we'd want to make sure the NHRP statements are both on the tunnel interface on this spoke, as well as on the virtual template that it's referring to with the IP NHRP shortcut command. And on the hub, we'd want to make sure the network ID statement and the redirect commands were enabled for the spoke-to-spoke connectivity to work. Now, because we do a virtual access interface already up and running, that also implies that our tunnel 0 to the hub is working, and also our virtual template is working, because we have an active session over to R3. Now, it is possible that maybe we haven't initiated any traffic over to R2, and that would be another valid reason why we don't have a security association directly between us, R4, and R2. Maybe we haven't sent any traffic destined to a network that's sitting behind R2. If the spoke-to-spoke connectivity isn't working, and we know we have the configuration in place, and we want to look at some of the details, we can do a show IP NHRP traffic, and that can give us an indication if it's working or not. For example, from R4's perspective, where we're sitting, he's had a total of 5 resolution requests on the tunnel 0 interface. So he's been asking for NHRP resolution, and it's been successful at least once because he's currently built a tunnel directly up to R3. We also have the ability for NHRP traffic to travel over our virtual access interfaces as well, because the template itself is also configured with NHRP, just like the tunnel interface is. If we want to see what's inside of the IP NHRP cache, we can do a show IP NHRP. And currently, we've resolved 35.0.0.3 as the reachable address for the network 10.3.3, as well as the IP address 172.16.0.109. The 172.16 address is the interface address that was logically assigned to R3 during its IKE version 2 mode configuration between R3 and the hub. To verify routing, of course, we could do a show IP route and look at everything, or we could do a show IP route and just put in the prefixes that we're most interested in. So here's our next hop override route for 10.3.3, which is great. We also have this 10 network that was learned from the hub, and that was part of the IKE version 2 authorization policy, where the access control list on R1 specifically said, okay, I want to go ahead and advertise the 10 network to my spokes as they connect to me. And when those spokes see that 10 network, if they've got a packet for some 10 network and they don't have a more specific route, they're going to use the tunnel to send it up to the hub. And that will in turn trigger a redirect and the NHRP lookup so the spokes can start building direct tunnels between each other. So it looks like our routing is okay here on R4. Another really fun command is show crypto IKV2 stats. So how many active IKV2 tunnels do we have at the moment? We have some pretty intelligent call admission control built in to IKE version 2. It's saying, hey, you know what? By default, maximum of 40 IKV2 negotiations at any given time. The default for IKE version 1, I believe, was 1,000, which is way, way too many. And it's very likely with IKE version 1 that the router is going to go belly up way before it ever reached 1,000 clients trying to negotiate IKE version 1 tunnels all at the same time. It also accounts for incoming, outgoing, and rejected IKE-v2 requests. Another fun option for that same command, show crypto IKE-v2 stats, is the keyword exchange at the end of it. And this has several pages of output, but the cool thing is if you're having specific issues, it can give you counters to help us identify exactly what is the problem or what kind of problems we're having with the FlexVPN. Now, a big part of the problems that are likely to arise with IKE-v2 and FlexVPN are incompatible policies and or profiles. So commands like show crypto IKE-v2 proposal can show us what proposals are in place. If we want to see the IKE-v2 policies, we'd use the command show crypto IKE-v2 policy just to make sure we have compatible policies between the devices. If they're having problems building an IKE-v2 tunnel with each other, we want to make sure they have compatible policies. On the IPsec side of the house, we need to make sure we have compatible transform sets that are going to be used by the IPsec profile. To verify those, we can do a show crypto IPsec transform-set. And to see the IPsec profile, the command is show crypto IPsec profile. And remember, the defaults are a great thing. However, they can be modified or changed. And if they're changed and we're not aware of that, that's going to give us unexpected results. And they're usually going to be negative. If we want to see the authorization policy, the command is show crypto IKE-v2 authorization policy. And that way we can verify, okay, what is the access control list that's being used as far as advertising routing information? Or are there restrictions on what networks I'm able to learn via this IKE-v2 tunnel? Another command that I find very handy is a show run, but without having to look at everything, a pipe section crypto. And that's going to show you all your crypto related commands. So if we hit spacebar a couple times, we may have to sort through a little bit, but it's a lot better than sorting through the entire running config. So there's our authorization policy, there's our IKE-v2 proposal, there's the IKE-v2 profile, here's the IPsec profile, and I don't see an IPsec transform set, and that's very likely because we're using the default. So because it's in its default state, it's not going to show up here. But what we could do is we could do the up arrow key, show run, and add the keyword all, pipe section crypto, and that will show us everything regarding cryptography, including the defaults, which are normally not displayed. It's now showing us the default IPsec transform set. It's showing us the default regarding the IPsec profile regarding lifetime, and all the other crypto defaults that don't typically show up with a show run. So to thin that out just a little bit more, I'm going to do a show run pipe section crypto. If we haven't tweaked the defaults, the default parameters are probably not causing us harm. So I'm going to bring that back a little bit with show run pipe section crypto as opposed to show run all. And if we want to look at the profile, we can simply look at it. Again, that's an easier way, at least for me, of taking a look at sections of the configuration instead of scrolling through the whole thing. So in this example, we're using RSA signatures for authentication. If the other side didn't have a compatible IKE-v2 profile, or if the other side didn't have digital certificates, which would prevent them from using RSA signatures, that also could create a failure of an IPsec tunnel between two spokes. Now, in the old days, we used a mechanism called a crypto map, where a crypto map would say, if traffic matches this crypto ACL, then let's go ahead and set this peer and apply this transform set and go to work with cryptography. Now, with the new FlexVPN, we don't use that legacy command, crypto map. However, internally, in the mind of the router, it is still logically thinking about crypto maps. If we do a show crypto map, it will show us the information regarding our security associations. So show crypto map is an older command that still works on the newer technology. We could also use commands like show crypto session, which is a fantastic option. And we've used that throughout the course. Show crypto session is going to show us information about our IKE-v2 sessions and the children essays associated with those IKE-v2 sessions. And if we want to see the detail about any of the IKE-v2 sessions, the command show crypto IKE-v2 essay with the detail option at the end of it will show us additional details regarding those essays. And of course, if we want to dig into the children essays, the IPsec essays, the syntax would be show crypto IPsec essay. And that's a lot of great detail regarding these specific IPsec essays if we ever need to drill down and look at that level of detail. So regarding troubleshooting, holy shnikers, everything looks good. Let's do a few casual pings. I did break something, so we can go ahead and solve it right here. Let's do a ping to 10.1.1.1. That's the subnet hiding behind R1. Looks like we have reachability to that. Next, let's do a ping over to 10.3.3.3. That's the subnet hiding behind R3. Looks like we have reachability to that. That looks great. And in our show commands, we saw IKE-v2 tunnels between ourselves and R1 and ourselves and R3, but we didn't see a tunnel between ourselves and R2. Let's go ahead and ping 10.2.2.2. That's the subnet hiding behind R2. and see if that flies. Now, it doesn't look like that's working. So as far as our troubleshooting goes, we know that we have basic connectivity between us and the hub. We have basic connectivity between us and another spoke, R3. So what's the problem with R2? We know we can ping the outside interface of R2. We tested that as one of our first steps. So if R4 can't reach the 10.2.2 subnet, maybe the hub can. So we'll make a road trip. We'll go up to the hub and we'll issue that same exact ping. So on the hub, let's go ahead and do a ping to 10.2.2.2 and see if he can ping it. Wow. So the bad news is none of the pings made it, but the good news is that 3 of those pings didn't time out. The router knew, hey, I can't reach this. Either it knew it by itself or it got an unreachable message from some other device. Because our VPNs are heavily dependent on routing, let's do a show IP route for 10.0.0.0 and see what routes we have. So in this list of 10 networks, we know how to reach the 10.3.3, that's our 3 subnet, and 10.4.4, that's our 4 subnet, but I don't see a 10.2.2. Now this is a routing issue. Now why aren't we learning this? If R1 and R2 have a tunnel between them, and let's verify that. Let's do a show crypto session to see if they even have a tunnel. And this output says yes they do. There's an active working tunnel between R1 and R2. So that means we have compatible policies for IKE version 2 as well as IPsec because the tunnels are up, meaning the IKE v2 and the children essays based on this output. But how come we're not learning about the 10.2.2 network? And one of the possibilities is that R2, maybe in its authorization policy, isn't advertising the 10.2.2 network. And that would be one reason why R1 doesn't know about it. So let's make a road trip up to R2. And let's ask R2, hey, can we please see your IKE v2 authorization policy with the command show crypto IKE v2 authorization policy default. Now in this default policy that it's using, it's saying, okay, the routes in this access control list, R2-route-ACL, I'm going to advertise those routes up to the hub. So our next logical question might be, what's in that access list? We can find out with the show access-list. And it looks like we have 10.2.2. Now that looks like the right network. It really does. However, what the problem is that is not the same access control list that's being referred to in the authorization policy. Up here it's calling on R2-route-ACL, and the only access list on this router is called R2-ACL. It's close, but it's not close enough. That access list has to exist, and it has to have the correct network in it. So to fix that, I suppose we could delete the other access list. However, we'd want to make sure we knew where it was being used before we just go ahead and delete it. In this demonstration, let's just create the new access list called R2-route-ACL. We'll identify the 10.2.2 subnet. And with that done, let's go ahead and clear crypto session to wipe out our IPsec and IKE v2 sessions between R2 and R1. That way they can renegotiate, bring that tunnel back up. And based on the authorization policy, R2 can now advertise the 10.2.2 network up to R1. If we go back up to R1 and issue the command show IP route for 10.0.0.0, hopefully we'll have a 10.2.2 subnet there. And I'll tell you what, he barely made it. The virtual access 2 interface just came up. That's for the tunnel between R1 and R2. And there's that 10.2.2 network. So now that R1 knows about it, and R1 is advertising a 10.0.0.0/8 network down to all its other spokes, now if R4 tries to reach the 10.2 subnet, it should send the request up to R1, who should send a redirect. R4 should do the NHRP and build the tunnel directly over to R2. At least that's the plan. So back on R4, if we do a ping now to 10.2.2.2, what should happen, if it works, is we should have a new tunnel that's brought up using a virtual template to create the virtual access interface. And if we do the pings again, because now the tunnel's up, we should have a complete success of all 5 pings. And now if we do a show crypto session, it should indicate we have an IKE v2 session between us and R1, which is this one right here, between us and R2, the one that just came up on virtual access 2, and the one we saw previously over to R3 on virtual access 1. To assist you with your practice, I've included all of the show commands that we've done in this video in this document called Troubleshooting FlexVPN. Now when it comes to troubleshooting FlexVPN, whether we have hub and spoke or point-to-point or even spoke-to-spoke configurations, a lot of the basics apply to all of that. For example, we need compatible IKE v2 policies and proposals. We need to have compatible IKE v2 profiles regarding how we're going to authenticate and identify a peer. We need to have compatible IPsec security associations. And the ingredients that go into that is the IPsec transform set and the IPsec profile. And those elements apply to all of them. And then when we get into hub and spoke or spoke to spoke, it's just because we have additional configuration added on top of it that we would also want to check. For example, authorization profiles and the NHRP commands that would also need to be present in that type of an environment. I have had a great time in this video. I'm so glad you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.